Okay, so I may have lost you on this one a little bit, and that's definitely my bad. So I wanted to go over it all over again. Okay, so here is our pulley that definitely has a mass, right? So this pulley has a mass, and it is going to have a force going this way, which we are going to call force tension left. It's also going to have a pulley going this way, which we are going to call force tension right. Now, something we need to think about here is there was a little box right here, so we'll call this little m. And that little m will have two forces acting on it, going like this, right here. And so that is also going to be force tension right. But that's why I'm just going to leave that right there. And then there's a force going down, which is little mg. Okay, now let's go back to here. So there's a big box right here, which has got big M on it. And it is going to have a force going up, which is also going to be force tension left. And then it's going to have another force going down, right, which is going to have big mg. Now, as we can tell, the acceleration is going to be going like this. Okay, so we know that right there. The acceleration is going to be going like that. Now, first thing I want to talk about is our sum of the torques right here. So what we're going to do, excuse me, is we're going to talk about our torque. So right here, we're going to have sum of our torques, which is going to equal I alpha. And what is that going to equal? Okay, so let's take a look here. Well, it's going to first equal R, force tension left. Everybody good there? If you didn't know, maybe I can draw this out here. This distance is R. Okay, so force tension left. So that is going to be spinning it clockwise, right? Okay, and then it's going to be minus the same R, force tension right though. Everybody good there? Okay, because that's going to be this side right here. This green part right here is going to be kind of spin it counterclockwise. So that's going to be the sum of my torques right there. Now, I'm going to rewrite this a little bit. So I have R, force tension left, minus R, force tension. Oh, sorry, let me kind of, whoop, there we go. R, force tension, right, equals I alpha. Now we know I alpha is going to equal I, which is going to be A over that big R right there. Now what we can do is we can divide basically both sides by R, like kind of divide both sides by R, and what's that end up going to be doing, which would be kind of neat, is that will cancel out these R's. But for the other thing, what I'm going to end up having is force tension left, right, minus force tension right is going to equal I over A over R squared. Now there's a couple different ways we can write this just to make it easier later down the road. What it's going to end up looking like is basically I over R squared times A, because we're going to eventually trying to solve for that A, but we still don't know our force tensions. So I'm going to slide this up a little bit. What we're going to start doing is our sum of the forces, right? So we're going to do the sum of the forces. We're going to keep with our color coding here. We're going to do the sum of the forces on the left-hand side. So sum of the forces on the left-hand side. We'll just call it like that. Okay, so sum of the forces on the left-hand side. All right. So sum of the forces on the left-hand side is going to equal, so we know it accelerates, so it's equal big MA, right? Okay, so big MA. And then, what are the forces going on? Well, there's going to be big mg and minus force tension in the left-hand side, correct? So the left-hand side, right? That's minus because, you know, it's going up, but we're going to call up going down. You get the idea, mg, so ultimately, this way is going to be positive for this one, right? Okay, so that was going to be positive. Okay, just trying to make sure. Okay, now let's do sum of the forces in the right-hand side equals. Okay, so they are also going to equal MA, right? Why? Because this way is going to be positive, right? Okay, so MA is going to equal what? So now this time, we're going to have force tension right, minus, and remember that's a little mg. Boom. Okay, so I'm just going to sort of sum up our equations right now, just so you can kind of all see them at once. So I have big mg, right, minus force tension left equals big MA, one equation. I also have force tension right minus little mg equals little mg. And I got one more equation here. I have force tension left minus force tension right equals, and then we have I over r squared times acceleration. Now ultimately, I have three unknowns, correct? I don't know, use this color, I don't know force tension left, I don't know force tension right, and I don't know acceleration. Oh, that is an M8, which is this acceleration, which is this acceleration. Same thing, force tension left, force tension right. So I have three equations and three unknowns that we have to get rid of to sort of get our equation in order. Now, I add all those three equations together. So if I add those equations together, which is kind of cool, what's going to happen is this and this are going to go away. And this and this, they're both going to go away. And basically, I have them all together. So we're going to rewrite our equation. Let's go back to our black pen here. So we're going to rewrite our equation now. So now I have mg, big mg minus little mg, right, equals big MA plus little ma plus, because this is the side with all the a's, I over r squared times a. Boom. There we go. So now I have all of that. Okay? So again, if you're adding all your three equations, I have all the a's on this side, all the force tensions on, basically on the other side of the equal sign. So just when I add them all together, right, they're all going to sort of go away. Right? So positive force tension R, negative force tension R, negative force tension left, positive force tension left. So when I add all the equations, they go together away, and then all these get put together. So that's how we end up getting this. So we got mg minus mg, and then that's it. These are that is what's left. Hopefully that made a little bit of sense. I'm happy to go over that with you more if you would like, though. So now I'm still trying to solve for a. So my acceleration, because if I could do some simple arithmetic here, or simple algebra, which I'm pretty sure most of you can do. I know some of you probably rolling their eyes. Why couldn't you do this in class? I don't know. I can't tell you why I couldn't do it in class. It was just one of those days. So if I work this all out, what I end up getting is acceleration equals big mg minus mg all over big M plus little m plus I over r squared. Now, this is the thing where I wanted you to write the other one down for when it was a massless system, because that's when it has a mass. But if it's a massless system where the mass of the wheel no longer matters, you don't need torque, it's mg minus mg, that's supposed to be a little mg, right? That's supposed to be a big mg there, and it's a little mg, all over m plus m. Notice, what's the difference? This piece. That's your rotational inertia, and that is what adds back in there. Gentlemen, I am very sorry I didn't do a very good job of that. That's definitely my problem. I apologize for that. But here is your video. I'm going to upload this to YouTube, and I would like you to make a comment on it to make sure you saw what it was, and just say, hey, I looked at it. Please. I know you could make the comment without looking at it, but please make the comment. That's it.